area versus surface area versus volume. When dealing with two-dimensional shapes, we could be asked to calculate the outside edge of the shape, the perimeter, or the inner coverage of the shape, the area. In three-dimensional shapes, we are going to be looking at the area of all the faces of the shape together, the surface area, or the space inside the shape, the volume. In order to make the distinction between these concepts, let us imagine Richard's rectangular fish tank. We see that there are three pairs of faces or sides, the top and bottom, the front and back, and then the left and right sides. If we zoom in to focus on just one of these faces, the outside edge is the perimeter of the shape, measured in units, and the inner coverage is the area of the shape, measured in square units. Zooming out, if we combine the area of all the faces, then we will have calculated the surface area of the fish tank, measured in square units, since it is area. It is the outside of the shape that Richard could touch. How is this different to volume? Richard fills up the fish tank with water. Now that the space inside has been filled, that is the volume, and it is measured in cubic units. Therefore, Richard has demonstrated the difference between perimeter, area, surface area, and volume. Thank you, Richard.
Let us explore a little bit more about rectangular prisms. So, if we take an example like this cardboard box, this is a rectangular prism because our sides are rectangles. We also see that the reason we call it a prism is because we have one face that can be repeated behind itself to create the depth of a three-dimensional shape. This is just like pages in an examination pad, where each examination pad page is a rectangle, but all the rectangles on top of each other create a three-dimensional shape. So if we want to calculate the volume for this box, what we would have to do is calculate the area of one side of this box and then multiply by the height or depth of the three-dimensional shape. So this is a rectangle, and the area of a rectangle is length times breadth. But then we've got to multiply by this depth, and I'm going to call that a height. And that's simply my formula. Three things to be multiplied. Well, let's calculate the volume of this box. Well, I have previously measured that the width of this box is 23.5 centimeters. This length of the box is 30.5 centimeters, and the depth is 30.5 centimeters as well. So if we type this in, we have a 30.5 times a 23.5 times my depth, which is 30.5. Type that into the calculator, and we end up with 21860.875. In other words, 21,860 centimeters something, but I'm going to get to that, 0.875. Now, why did I seem to hesitate on centimeters? Well, this is centimeters times centimeters times centimeters. So just like in algebra, if you have x times x times x, you get x cubed. This is not going to be centimeters. This is going to be centimeters cubed. And having this cube unit is the identifying characteristic of volume. But now that we've calculated this, we know exactly how much we can store, and we can never go wrong. let us have a closer look at cubes and how they are different to rectangular prisms. If I take a cube, for example, this tissue box, we can see that the difference between this and a rectangular prism is that every face or side of this shape is a square, not a rectangle. So we can also see that because this is a prism, we can calculate the area of one face and then multiply by the depth that makes this a 3D shape. You can imagine it as similar to an examination pad, where each of the pad pages is the 2D shape, and the amount of pages you have that you put together makes it the 3D shape. So we can see that if we are going to be calculating the volume of this shape, it is simply going to be the area of this square times by the height or the depth. So how do we calculate the area of this front face? Well, the area of a square is the one side times the other side, but being a square, they are equal in length. So that would be the one side times the other side. But if we times by the depth, this side is the same as that side. Therefore, this depth is the same length again. And therefore, it is simply the side length cubed. So if I say to you, calculate the volume of this tissue box, well, I've measured that this tissue box is 11 centimeters across. So therefore, this will be 11 cubed, and that is 1,331. But what units are we dealing with? Well, each one of these measurements, I said was 11, and I said what? It was 11 centimeters. So therefore, the unit must also be cubed, because you're multiplying centimeters by centimeters by centimeters. And therefore this would be the volume of this tissue box, and knowing this, we can't go wrong. Let's have a bit of a closer look at a triangular prism. So, as an example, we could have a look at this Toblerone box. We can see that there is a triangular face, and that shape is carried through my triangular prism. That is the idea of a prism, that you have one face that is repeated behind itself to create depth, and that creates the three-dimensional shape. So therefore, to calculate the volume of this shape, all we would need to do is calculate the area of this front face and then multiply it by however long or whatever the depth is of this shape. So therefore, to calculate the volume, we're going to have to calculate the area of this triangle. And remember, the area of a triangle is a half times the base times my perpendicular height. So in other words, I need to take one side of this triangle as the base, and then a perpendicular distance up to the other vertex or corner. That will be the area of the shape times by its depth, and I'm going to label that as capital H. So let's measure the volume of this Toblerone box. So I have already measured that this horizontal distance was 6, and that is 6 centimeters. And this vertical perpendicular height was 5 centimeters. The depth of this was 30.5 centimeters. So let's sub that into my formula. It is a half times my base, which was 6 centimeters, the perpendicular height, 5 centimeters, and the depth, which was 30.5 centimeters. So therefore, multiplying all of these on the calculator gives me 915. But 915 what? We are multiplying centimeters by centimeters by centimeters. So just like in algebra, if you have x times x times x, you have x cubed. Here, you would have centimeters cubed. And having a cubic unit is the identifying characteristic that we're calculating volume. But now, you know exactly the volume of how much chocolate you're going to eat. Archimedes and the Golden Crown. Archimedes was a Greek mathematician, scientist, and engineer who lived in Syracuse over 2,000 years ago. The king, Hiero, wanted to show his gratitude to the gods for his success and good fortune. He weighed out a precise amount of gold to create a crown worthy of the gods in the shape of a laurel wreath. He appointed a goldsmith and commanded him to fashion this golden wreath. The goldsmith took many days to create it, but once created, the king was very pleased with the result. The weight of the wreath was equal to that of the gold given to him. Therefore, the king was happy and paid the goldsmith for his services. A few days before the unveiling of the crown, the king heard rumors that the goldsmith had mixed silver into the crown. He needed an ingenious way of testing if the rumors were true, but without damaging the crown. So, the king approached the only man in Syracuse that he believed would be able to solve this problem, Archimedes. Archimedes only had a few days to solve it, but managed to in a rather unusual place. He went to the public baths and was thinking,
how could I check if there's silver in the crown without breaking it?
He lowered himself into the bath and found that the water spilled over the sides of the bath. As he lowered himself further in, more water spilled out. At this point, he realized that he could use this to measure the volume of the crown. He knew he had solved the problem and jumped out of the bath screaming, "Eureka! Eureka!" meaning,
I've found it! I've found it!
and ran home. Unfortunately, in his excitement, he had forgot to put his clothes back on. He had realized that the volume of his body under the water was the same amount of water that was displaced. The goldsmith, knowing that silver is lighter than gold, would have to have put more silver into the crown than the equivalent amount of gold to ensure the crown weighed as much as the gold. However, this would make it displace more water than the original gold amount. When tested in front of the king, it did indeed displace more water than the gold, and the goldsmith was proven to be a fraud. Archimedes' method for measuring the volume of irregular shapes became famous, and the rest is history.
In this lesson, we will talk about the sides of a right-angled triangle. We will then discuss the theorem of Pythagoras. We will then look at 2 examples, and to end off, we shall recap everything we have just learned. So let's discuss the sides of a right-angled triangle. We have side 1, which is over here. We have side 2, which is over here. And then we have the hypotenuse. So now, the important thing is to identify the hypotenuse. It is the side opposite the 90 degrees. It is also the longest side in a right angle triangle. This brings us to the theorem of Pythagoras. The theorem, stated in words, is: in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So what this means is the hypotenuse squared is equal to the sum of the other two sides squared. So side 1 squared plus side 2 squared. Usually you'll find the Pythagoras theorem is stated as follows. So they give you a triangle A, B, and C. As you can see, the side opposite your right angle is your hypotenuse. So this is the hypotenuse. This here is side 1, and this here is side 2. So often they like to write Pythagoras' theorem as c squared equals to a squared plus b squared. So that's why it's so important to correctly write down the hypotenuse. Side 1 and side 2 aren't as important, as you can interchange them. Let us look at an example. So given the triangle below, what is the length of the hypotenuse? The hypotenuse is the length opposite the right angle, so it's this. I'm going to call it C. So this means our A equals to 4 meters and our B equals to 3 meters. So recall, Pythagoras' theorem was c squared is equal to a squared plus b squared. So c squared equals to 4 squared plus 3 squared. This is equal to 16 plus 9, which is equal to 25. So c squared equals to 25. Therefore, c is equal to the square root of 25, which is equal to 5. We only take the positive square root because this is a length, and we can't have a negative length. So our answer is the hypotenuse is equal to 5 meters. Let us look at another example. So given the triangle below, what is the length of the unknown side? So firstly, we identify the hypotenuse as the side opposite the right angle. So C equals to 13. So we have A equals to 5 and B equals to question mark, because we don't know what B equals. It's unknown and we wish to find it. So recall, Pythagoras' theorem said that c squared is equal to a squared plus b squared. So we have 13 squared is equal to 5 squared plus b squared. So 13 squared is equal to 169, which is equal to 25 plus b squared. Bringing that across, we get 169 minus 25, which is 144, and this is equal to b squared. Now square rooting both sides, we get that 12 equals to b. we only take the positive because the negative square root is not valid, as this is the length of a side, and we cannot have negative lengths. So therefore, the unknown side is equal to 12 centimeters. Let us recap everything we have just learned. So, stating Pythagoras' theorem in words, we have, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So looking at a right-angled triangle, the hypotenuse is always opposite the right angle, and then you have side 1 and your side 2. Writing Pythagoras' theorem more mathematically, we write the hypotenuse squared is equal to side 1 squared plus side 2 squared. Or if we use the triangle with the hypotenuse in C, and we have A and B, we get C squared equals to A squared plus B squared. This is the most common way of representing it, as it is simplistic but contains all the information of the theorem. So it's like a nice summary of the theorem. Plus, you can use this formula directly. In this lesson, we are going to look at 3 examples that involve the Pythagoras theorem. These are more complex examples. And to end off, we shall recap what we have just learned. Let us look at an example. So is the following a right-angled triangle? So remember, Pythagoras theorem said, so if you have a triangle, it's a right angle, you have a hypotenuse C and your other sides are A and B, then your hypotenuse squared is equal to the sum of your other two sides squared. So we want to see if this is in fact a right angle. The reason I chose this, because the hypotenuse is the longer side of any triangle. So if we're testing if we have a right angle, choose the longer side to be the hypotenuse. So we let our C equal to 15, our A equal to 10, and our B equal to 5. So now, if A, B, and C follow this rule, then we would have a right angle. If not, this would not be a right angle triangle. So, C squared is equal to 15 squared. This is equal to 225. A squared plus B squared is equal to 10 squared plus 5 squared. This is equal to 100 plus 25, which is equal to 125. So now, is C squared equal to A squared plus B squared? Well, 225 is not equal to 125. So C squared is not equal to A squared plus B squared. Hence, this is not a right angled triangle. Let us look at another example. A 4-meter ladder is rested against a wall. The ladder touches the top of the wall. If the base of the ladder is 2 meters from the base of the wall, how high is the wall? So we start off by first drawing a diagram. So here's our ladder resting against the wall. We said the ladder was 4 meters. And the base of the ladder was 2 meters from the base of the wall. How high was the wall? So, composing this into a triangle, which is easier to work with, this would be the wall, and it would be our unknown. This would be the ground, and it would be 2 meters, and this would be our ladder, and it would be 4 meters. So, we have a right angle triangle. This would be our hypotenuse. This would be our side 1 and our side 2. So recall, Pythagoras' theorem said that the hypotenuse squared is equal to side 1 squared plus side 2 squared. So 4 squared is equal to a squared plus 2 squared. So we get 16 is equal to a squared plus 4. Bring the 4 across, so we get 12 is equal to a squared. Therefore, a is equal to square root 12. And when you simplify this, it's equal to 2 root 3. So a is equal to 2 square root 3 meters. It's better to leave it in surd form, although if you wanted to put it as a real number, it would be approximately equal to 3.464 meters. So generally, leave your answer in surd form. This is because this is the exact answer, whereas this has been rounded off.
When the live game's about to start but you're stuck here, we've got an app for that. Missing your favorite show because the fridge is running low? We've got an app for that. Stuck watching what she wants to watch? We've got an app for that. Waiting for the bus? App for that. Working late? App for that. And if the power goes out, we've got an app for that too.
All for you.
The DSTV Now app is the entertainment solution for anything life can throw at you. Simply download the app from your app store and add your DSTV account information to activate the app and start watching. Whenever, wherever you have a charged device and an internet connection, you have DSTV Now.
We always love to hear from you. Send us your views, comments and videos with your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV, it just gets better. Share with us on #LearnOn1. Tell us what you're learning and where you're learning it from. Send us your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV, it just gets better.
morning, grade 12s. Today we have a self-assessment on logarithms. Please print this out, do the exercise, and then you can watch the lesson.